Solving equations. These will have the same bases. We are going to deal with a rule that says if we take the log base a of a to the x power, and that's the same a, then everything cancels out, we end up with just x. This is because a log and an exponent function are inverses of one another. This is one of the easier rules very nicely. So we'll start with a nice simple beginning problem. Log base 12 of 12 to the 5th power is just equal to 5. The log base 12 and the 12 sort of unravel one another, and we just end up with 5. Again, this is because they are inverses of one another. This next example will be log base 2 of 128. Now we can see that the base 2 here is not the same as 128. However, if I prime factorize 128, meaning I break it down with its tree, 128, and I divide it by 2, 64 times 2, then I can break 64 down to 2 times 32. I'm going to end up with a whole bunch of 2's. In fact, if we keep breaking that down, we will end up with log base 2 of 2 raised to the 7th power. 16 up here actually breaks down to 4 more 2's. So we'll have the 3 2's along the line here, and then we'll have the 16. And very nicely, we have the same base now. We have log base 2 of 2 to the 7th power, and everything collapses down to just 7. This is really the best way to go if you can make the bases match like that. More often than not, you cannot. We'll just try a couple more examples. Log base 3 of 1 over 81. Now, 1 over 81 obviously is not 3. However, 81 breaks down as well. We could do a little tree off to the side if we needed to. And we would see that 81 is the same thing as 3 raised to the 4th power. Now, 1 over 3 to the 4th power is still not base 3 quite yet. We'd need to do a little more manipulation. Log base 3. And if you think back to your exponent rules, if you have a positive exponent in the denominator, that means you can actually bring it up to the numerator, and it becomes a negative exponent. So this is like 3 to the negative 4th over 1. It's like I took the reciprocal. And very nicely we can see log base 3 of 3 to the negative 4 power. Everything collapses down very nicely, and you get negative 4. Some of these you will have to do the tree like we did to the 128 up above to see if it really is the right base or not. If it's not, then this rule that we're using right now will not apply. Let's do one more example. This will be a fancy one. Log base 9 of 3. Now you can kind of see that there's a connection between the 3 and the 9, and there is. And we got to get a little tricky here. And I can't mess with the base, so I can't change the 9 down here. That's part of the problem. However, I can do some manipulation to the 3 on the inside. And the connection here, log base 9 of 3 is the same thing as the square root of 9. Now, you've learned this semester some new rules with exponents. And when you have the square root of 9, that's the same thing as saying that this is now 9 raised to the 1/2 power. And now we have, finally, log base 9 of 9 raised to the 1/2 power. So the 9's, again, unravel one another. We end up with a 1/2. And there you have it.